Hello, today's lesson is 2.2. We're going to talk about slope and rate of change. Many of you may have only heard the term slope, but slope and rate of change are the same thing. And you know that the variable that represents slope is m, and I'm sure we've all heard that your slope is your rise over your run when you're graphing it. That is also another way to say that is the change in y over the change, in x. So if you're rising, you're changing your y values. If you're running, you're changing your x values. That little triangle just means change. And then the famous slope formula, y2 minus y1 over x2 minus x1. Now, you guys all know this about slope, but for some reason, if I give you a line, the positive, the negative, all that kind of stuff always gets switched around. So here is a little diagram that will help you remember whether something's positive, negative, zero, or undefined. So imagine a little man walking up a hill. If you're going uphill, you have a positive slope. And then he gets to the top and he comes back down. Boop, boop, boop. Now you have a negative slope. So when you're going uphill, it's a positive slope. If you're going downhill, it's going to be a negative slope. And then he gets on flat ground, it's going to be 0. And he keeps on going, he gets to the cliff and he falls off. And if he falls off, he's no more, so he is undefined. So a good way to remember whether something's positive, negative, 0, or undefined. Again, slope is the same thing as rate of change. The bigger the slope, so the larger the slope number is, so if m is 1 or m becomes 10, the bigger that number of the slope is, the steeper the line. So the bigger the slope, the steeper the line, because that means the faster you're moving, the faster you're climbing up. Parallel lines, you all know that parallel lines have the same slope. And perpendicular lines, there's two things that must happen. If you only do one of them, they're not perpendicular. You need them to be the opposite. So one has to be positive, one has to be negative, and reciprocal. So you've got to flip your fraction around. Finding the slope of two ordered pairs. So we've got y2 minus y1. So we've got 1 minus 5 on top. 2 minus a negative 3 on the bottom, so that becomes a positive. We've got a negative 4 over 5. So the first part of the battle is to find that slope. Now if we want a parallel slope, if we want parallel, we want exactly the same. So all I gotta do is recopy. Negative 4 over 5. Perpendicular, I need the opposite, so the opposite of a negative is a positive. And then the reciprocal of 4 over 5 is 5 over 4. Do you have to write the positive sign? No. I'm just writing it there so you guys don't forget. Alright, next one. 3 minus 2 on top. 14 minus 4 on the bottom. 3 minus 1 on top is 1. 14 minus 4 on the bottom is 10. So our given slope is 1/10. Parallel, we want exactly the same, so we just write 1 over 10. Perpendicular, we started with a positive, so now I'm going to have negative. The reciprocal of 1 over 10 is 10 over 1. Please, 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 please do not write negative 10 over 1. You know that negative 10 over 1 is just negative 10, so just give me negative 10 as your answer. Last ordered pair 1, 1 minus 4 on top, 8 minus 8 on the bottom. So we've got a negative 3 over 0. Hopefully you guys are all, little lights going off in your head. You can't have 0 on the bottom, so this is undefined. A good way to remember this, if 0 is under, it is undefined. So 0 can be on the top. We know that 0 over negative 3 is 0, so we'd have a slope of 0 there. But if 0 is on the bottom, then it's undefined. So our given slope is undefined. And hopefully you know that undefined slopes correspond to vertical lines. Every vertical line is going to have an undefined slope. So if it's parallel, if I have one vertical line that's undefined, the only way to have a parallel line is to have the exact same. So I'm going to have yet another vertical line right next to it. Now perpendicular. Let's think about a graph. If I have a vertical line and I want to create a 90-degree angle so that's perpendicular, the only way to get that is if I do horizontal. That will give me that perpendicular angle. So if I have a horizontal line, the slope of a horizontal line is 0. And again, this is a horizontal. So that's your one special case where you don't do the opposite reciprocal, because vertical and horizontal lines are special. They've got different equations, they've got all different kinds of different properties going on. So let's look at slope from a graph. Number 1. When we look at number 1, we have a horizontal line, therefore our slope is 0. For number 2, it's not horizontal, it's not vertical, so I actually have to count our rise over run. And when you're looking for the slope, pick good points. When I mean good points, points that go directly through the corners. If it's halfway through, it's not going to be good to count. So I'm going up 1, right 1. Well, 1 over 1 is going to give me a slope of a positive 1. Let's go here next, number 3. Number 3 is a vertical line, so your slope is undefined. And last but not least, we've got our 4th line down here at the bottom. Now this is what I was talking about good points. I would not pick this point right here because it's not good. It's not going directly through a corner. Here we've got a corner, and here. So make sure it's going directly through. I'm going down, so that's a -1. I'm going right 1, 2, 3, 4, 5. So it's a positive 5. And remember, your slope is rise over run. Your change in y over your change in x. So your slope is a -1/5. Next, trying to find the slope from a given table. If you're trying to find the slope from the table, you want to find your changes in y's and your changes in x's. So if I'm going from a -35 to a -11, I want to find out how much am I moving. In order to go from here to here, I'm going up 24. If I'm going from -11 to 1, I'm going up 12. I have to go up 11, I'm at 0, up 1 more to get to 1. From 1 to 19, I'm going up 18. From 19 to 38, I'm going up 18. This is where I would recommend drawing your pluses and your minuses so you don't forget whether your slope is positive or negative. -5 to -1, I'm going up 4. -1 to 1, we're going up 2, up 3, up 3. So this is going back to the very beginning. We said change in y over change in x. These are my numbers that are our change in y. So this is going to go first on top. So we've got 24 over 4. That gives me 6. Now we want to check all of our points if they're different. So we've got 12 over 2, which is 6. And we've got 18 over 3, which is 6. They all were consistent, so in this case our slope is 6. Guess what? We are on our very last problem for our notes for today. You are driving in Italy. You're on vacation, you're away from school. You are 420 kilometers from Rome at 9 a.m. At 3 p.m., you are 108 kilometers from Rome. What is your average speed? In order to figure out this piece of the slope, which is your average speed, because your rate of change is your speed, we need to kind of dissect our information here. So we have one piece of given information. You are 420 kilometers from Rome at 9 a.m. The second piece that we're given is that you are at 3 p.m. you are 108 kilometers from Rome. We're going to take this information and we're going to write it into ordered pairs. But what you need to remember from the other day is, how do I write this? Well, we know an ordered pair is written x comma y. We know that. And the other day we learned that the x is the independent variable and the y is the dependent variable. So we have to kind of read through this and decipher which one is independent, which one is the dependent. In this case, your distance you've traveled is going to depend on how long you've been driving. So distance is going to depend on time. You wouldn't say that the time is going to depend on how far you've driven. How far you've driven is going to depend on how long you've been driving. So distance depends on time, therefore different distance is the dependent. And time is the independent. So when we write our ordered pairs, your time is going to come first. So our ordered pair we've got is 9 a.m. And at 9 a.m. we are 420 kilometers. Then at 3 p.m. we are at 108 kilometers. So we're getting closer to Rome. So if we're going to find our slope or our rate of change, our speed, we want our change in y over our change in x. And y in this case is our distance. So we're going to find our change in distance, 420 minus 108. And then our change in x, our change in time. Well, we started at 9 a.m. and we went to 3 p.m. So between 9 a.m. and 3 p.m., how much time has actually passed? Don't just do 9 minus 3 and tell me 6, which in this case actually is true. But you know, if you have to count, 9 to 10 is 1, to 11 is 2, to 12 is 3, from 12 to 1 is 1, that's 4 hours, 5 hours, 6 hours. So you've actually traveled 6 hours, and in those 6 hours you've gone 312 kilometers. Divide your numbers and you get that you are traveling at 52 kilometers per hour. It's always your top label over your bottom label. If you don't have kilometers per hour, you're not going to get full credit. You have a word problem. Whenever you have a word problem, you must have labels. Very, very important. Alright, that's it for today.